Hello guys, welcome to my channel. So in this video, let us try to understand an important topic of power electronics that is known as choppers. So basically we have choppers of 5 types. Those are class A, class B, class C, class D and class A. So we have 5 choppers in total in order to discuss. So let us start with class A chopper. Before going to learn about the class A chopper, let us try to know what is a chopper actually. A chopper is a circuit which converts fixed DC supply to variable DC supply. So one must know what is a chopper actually before learning it. So we can get variable DC supply using a fixed DC supply with the help of chopper circuits, and this can be achieved by choppers by controlling the thyristors or the SCRs which are present in the chopper circuit. So let us start the video with class A choppers. So this is a circuit arrangement for the class A chopper. So class A chopper means it is the first chopper and it will operate only in the first quadrant where the output voltage and the output current are positive. Before going to know the operation of this particular class A chopper, first let us make some assumptions here. That is, my load current I0 is flowing in this direction and the output voltage polarity is here plus, here it is minus. So I am assuming this as the reference polarities before going to the operations. Now let us see what happens. Here you can see there is a switch called S1. This is nothing but your chopper. You can write it as CH1 also. For simple understanding, I have written it as S1. So consider S1 as a chopper. So when S1 is switched on, when S1 is closed, I mean if I close this particular switch, what happens is my I0, that is load current, starts flowing as the circuit is completed here. So I0 will start flowing from VDC to S1. From S1 to it goes to R to L. Here L gets charged, that is inductor is getting charged, and it returns back to the source, that is VDC minus. Here it is plus. From plus it is starting I0 by through S1 R. L is getting charged here and getting back to the source, that is nothing but your VDC. So in this way my current is flowing, and if you see the current flowing and the reference current direction, both are same because my current is flowing in this way when the switch is closed. Before closing the switch also, whatever the reference current I have assumed, it is also in the same direction. So I can say that output current is positive because whatever that I have assumed and whatever that is actually happening in the circuit are same. So I can definitely say it as positive. So here in current direction there is a term called VDC. If there is VDC, we can definitely find whether the output voltage is positive or negative. So if you see here, the plus terminal is directly connected to the plus terminal of the output. So there is no polarity change between the VDC and V0. So what happens is your V0, whatever you have considered, I mean before the reference is here plus and here minus, but after closing the switch also it is remaining the same. See here you can observe it, the plus is connected to the plus terminal, so V0 is also positive, which means the first quadrant operation is satisfying as I said before. So let us see another condition also in this itself. So here the inductor is getting charged, so what should be happen now? It should discharge now. So let us try to understand. And when it discharges means when the S1 is off. So now the condition is when switch S1 is in off state. So when this is off, the I0 direction will be, see here, I will write it here. When S1 is off, what will be my current direction? So when switch S1 is off, which means it is open, So there is no connection between the source and the load. So what happens is, in previous case, L has stored energy as current is coming in this direction. Here it will be plus and here it will be minus. So while discharging, what happens is, here it will be plus and here it will be minus, because it reverses its polarity while discharging. So in this way my discharging current will flow now, like in this way, because it is not going in this way because here the switch is open. Switch is open means infinity resistance, whereas here I have a diode which is also forward bias. Forward bias means it is a closed switch, so definitely my current I0 will I0 or the inductor current will definitely flow through this particular diode, and we call this diode as freewheeling diode also. So my current is circulating in this way. So you can see that current direction is from L it is going, it is coming outside, that is from positive terminal, and it is going to diode D1 or D, from there again coming back to the source. So in this way here the inductor is finally discharged. So this is the current direction when switch S1 is turned off. So here also if you observe, whatever the current direction before it was there, similarly the same current is flowing. So I0 is again positive. As there is no VDC term involved in the current direction, we need not to talk about the output voltage. It will be definitely a positive. So in this way the class A chopper will operate. One more key point you have to remember is, always the chopper CH1, I mean chopper A is a step down chopper. Sometimes it is also step down or buck chopper, you can call it as step down or buck chopper, and it will operate only in first quadrant as explained above. So I hope you are clear now how a chopper class A chopper is working. Only one thing you have to remember is that first we have to close the switch, then the current will flow in this way. When you open the switch, the whatever the energy stored, that is stored in the inductor, will freewheel through this particular diode, so it will circulate in this loop. That's it. Here plus is connected to plus, so the voltage is also positive, current is also positive, because both the assumed and the actual current directions are same. So this is the working operation area in the quadrant graph. So this is about class A chopper. In our next video we will learn about class B chopper. Thank you guys for watching this video. Definitely I'll share this PDF link in the description area, and if you like this video, please like, share and subscribe to my channel. Thank you guys.